Welcome to our new learning. This time we have another topic, which is the how to calculate voltage drop for large industrial motors. So medyo kakaiba yung topic natin, which is about large industrial motors, or other term as easy induction motors, are essential for powering heavy machinery and processes, ranging from pumps and compressors to conveyors and machine tools, and can be ranged up to 500 horsepower to over 10,000 horsepower. Okay, so when we say large industrial motors, yung average ng rating niya is ito, 500 to 10,000 horsepower. So medyo malaki yung rating. Did you see on the screen? Actually, dalawang induction motors yung naka-install. Okay, so itong motors pala, they use electricity in order to operate properly. And then we have here actually a group of induction motors. For its application, so apply siya for pumps, driving pumps for water, chemicals, and other fluids. Compressors, powering air and gas compressors. For conveyors, conveyor belt, and material handling systems. As machine tools, so driving mills, drills, press, and CNC machines. For extruders, rollers, and mixers, used in various processing equipment. As robotics, so providing automated system. For its back system, so equipment, refrigeration, compressors, and cooling towers. For oil and gas industry, used in gas compressors and oil pumps. So malaki yung scope nitong large industrial motors. And again, with this content, let's discuss lang about the importance of voltage drop for these industrial motors. And then, assuming we have 500 HP induction motors, and then nakatap siya, if you say directly coming from motor control center, MCC, and then pag ganitong rating, so 500 HP, meron siyang 373 kilowatts true power, and then 438.82 kVE. So yun yung kanyang apparent power. Also given na rin yung line current, which is 575.82 amperes. So 440 volts, 3 pole. Also yung power factor indicated as 0.85. Okay, so yung ating gagawin ngayon is to determine the voltage drop coming from this motor control center up to this equipment. So let's look for the voltage drop here, or known as VD. Okay, but before that, we have PEC provisions that states that conductors for branch circuits size to prevent a voltage drop exceeding 3% at the farthest outlet, power heating, lighting loads, or combination of such loads, where a maximum total voltage drop both tweeters and branch circuit to the farthest outlet not exceed to 5% to provide reasonable efficiency and operation. So to interpret that, ang sabi is from source to distribution panel, we have less than or equal to 3%. For the distribution panel to the farthest load, we have 3%. So And then, mayroon siyang maximum a total of 5%. Okay, so yun yung condition na galing sa PEC. And then, to go with the computation, the next to do is, we need to identify the given. Okay, so first is the operating voltage for 40 volts, already given. Also, the total wattage, 373,000 watts. Okay, the true power. Also, the load amperes, the line current, that is 575.82 amperes. Power factor, which is 0.85. Yung length, which is 55 meters, given na din. Yung location is from motor control center, and then to our induction motor na 500 HP. And then yung feeder natin is 2 sets of 4 by 150 square mm. So dalawang sets na 4 na 150 square mm. And then to get for the resistance, we have a table coming from PEC 10.1.1.9. If used steel, that is 0.045. Okay, that value is coming from here. For the reactance, that is 0.051 ohms. And then that is, yung reactance natin is per 305 meters. Okay, so after that, we have a formula pag 3-piece circuits. Actually, this formula is coming lang dito sa PEC 2017, medyo simplified lang. Which is, the voltage drop, BD, is equals to I times square root of 3 times G, the impedance, times L over 305, and then multiply by 1 over N, where G is the wire impedance expressed in ohms. And then we have formula, G is equals to square root of R square plus X square. And then L is total length of wire in meters. N is the number of sheets. So voltage drop in 3-piece system, use line to neutral. Then next is the solution. So simply voltage drop BD is equals to 1.732 D times I. So yung D, ito na yung length, times square root of R squared plus X squared times 1 over 305, and then times 1 over N. Okay, so BD is equals to 1.732. Yung distance or yung length we have is 75 meters. Yung current, which is 575.82 amperes, is 1. Square root of 0.05 square, and then plus 0.051 square, multiplied by 1 over 305, because yung ating impedance from PEC is per 305 meters. And then 1 over 2. So yung N is the number of sets, and then we have 2 sets of our conductor. So after we got a calculator, we can arrive our voltage drop at 8.32 volts. So after that, we have VD in percent, that is 8.34. So divide mo lang to ng kanyang operating voltage, which is 440 times 100. So our voltage drop in percentage is 1.895%. So if you look on our provisions, so it states that from source or distribution panel, or let we say from distribution panel to power this load using ating motors, the maximum voltage drop must be 3%, less than or equal to 3%. But on our calculations, we have all 1.895%. so which is below 3%. So therefore our sizing for conductors is tama. And then to get for the receiving voltage of our load, which is 500 HP AC motors, so simply subtract itong 440 volts to our voltage drop 8.34. So we can have the answer of 431.66 volts. Okay, so and then to get for the receiving power, so that is square root of 3 multiply by our VL, which is ito yung ating sa receiving voltage 0.31.66 volts, times the current, which is 575.82 amperes, and then the cosine theta or the power factor, which is 0.85. And then after that, you can get the efficiency, which is the power output itong sa receiving power over the power input, which is 373,000 watts. And then you can have the efficiency of 98.10%. Yung voltage drop natin is 8.34 volts. So that is the parang losses of our conductor from this point to this to the load. So meron siyang 8.34 volts. And then the receiving voltage natin, itong na matanggap ni motor, is 431.66 volts. So hindi na purely 440 volts. But ito namang ating loads is nagre-range, meron naman siyang range na mag-operate with that specific voltage. But dapat pasok din siya dun sa mismong range ng voltage drop. Okay, so therefore for this calculation, our motors can work properly. Okay, so I hope you learned a lot with this short content. So please subscribe para updated sa upcoming videos ko. Thank you.